What we're going to talk about right now is factoring a higher degree polynomial using the rational root theorem. We're going to first list out all the possible places where this could cross the x-axis, just so I know points that I might have to test. So to do that, I take the factors of the last number and divide them by the factors of the first number. Now the factors of 12 are plus and minus 1, 2, 3, 4, 6, and 12. And the factors of 4 are 1, 2, and 4, plus and minus, of course. When I go about dividing, I'm going to divide everything by the 1, and that's going to get me all these same numbers, plus and minus 1, 2, 3, 4, 6, and 12. And then I'm going to divide them all by the 2, and I say 1 divided by 2 is 1 half, 2 divided by 2 is 1, 3 divided by 2 is 3 halves, 4 divided by 2 is 2, 6 divided by 2 is 3, and 12 divided by 2 is 6. I had a lot of repeats there, so that didn't really add anything to this. Now I'm going to divide them all by the 4. 1 divided by 4 is a fourth, 2 divided by 4 is a half, which I already have, 3 divided by 4 is 3/4, 4 divided by 4 is 1, 6 divided by 4 is 3 halves, which I already have, and 12 divided by 4 is 3. So again, there were a lot of repeats that I didn't have to test. But if you look at this is a lot of numbers, positive and negative, 1, 2, 3, 4, 6, 12, 1 half, 3 halves, 1/4, and 3/4 are a lot of numbers that we'd have to plug into this equation to see if one of them got me 0. So I don't want to test all those. So what I want to do is kind of narrow down my choices. So over my graphing calculator, I have the equation written in y1, and that is the only one that's going to be graphed when I hit the graph button. Now you can see it's going to graph here, and it looks like it's crossing 3 times. I don't really know where those 3 places are. Maybe I could kind of tell where that last point is. If I look at the table, that might be at 6. I don't really know. I'm just going to sort of guess. And so I'm going to go down here and look at 6 and see. Oh, 6 is up at 18. So it's close to 6, but not actually 6. In fact, none of these numbers in the tables are actually 0. So I'm going to have to test the points looking at the graph. Alright, well, I can see that it's crossing maybe next to 0, a little bit to the left of 0, so that's probably like negative 1/4. So I'm going to trace it, negative 1 divided by 4, and see what I get. Nope, that's not it. In fact, that's way above 0, and the only other point near there is negative 1 half, so I'm going to try negative 1 half, and just to be thorough, and no, that's not it either. Alright, so now I got to go to the right side there. I can see that it's crossing a little bit above 1, which would imply that it's probably 3 halves. So I'm going to try 3 halves and see what happens. And there we go. There's a good point. So one of my actual roots, actual zeros, is found at positive 3 halves. Now you can see that it's not going to have anything that is going to be rational for the one that's next to 0 or the one that looks like it's up close to 6 there, because I don't have any points that are near there. So those two must be irrational roots. And remember, irrational roots always come in pairs, the plus and the minus version of them. So what I'm going to have to do is actually write the factor that goes along with this positive 3 halves. And that factor that would get me 3 halves is 2x minus 3. Now when I pull 2x minus 3 out of the original equation up here, it's going to leave me something left over, and I'm going to use synthetic division to find that. So I'm going to put the negative, or the positive 3 halves that is my root in the box, and then I'm going to put 4, negative 28, positive 25, and positive 12 outside the box. Now doing some basic calculation, I bring down the 4, 3 halves times 4, 3 times 4 is 12, divided by 2 is 6. And then I combine those guys together to get negative 22. 3 times 22 is 66, divided by 2 is 33, which would be negative 33. And I'm going to combine those together, and that would be 8, negative 8. 3 times 8 is 24, divided by 2 is 12, which in this case would be negative, and that would be 0. Now remember, with synthetic division, since I had to have this 2 that's on the bottom of the numbers, this is not my actual answer. I have to divide these numbers by 2. 4 divided by 2, which would be 2x squared. 22 divided by 2 is minus 11x. And negative 8 divided by 2 is negative 4. Now if you wanted to check, you could see if that was factorable, the blue stuff, see if that was factorable, but I know that this is not factorable because two numbers that multiply to negative 8 will never add to the negative 11, so this is not going to be factorable at all. What we need to do is some other method, either completing the square or quadratic formula. In this case I'm going to use the quadratic formula. A negative version of b would be a positive 11, plus and minus the square root of b squared, which is 11 negative 11 squared minus 4 times a, which is 2, times c, which is negative 4, all over 2 times a, which is again 2. We need to just calculate this out. That would be 11 plus and minus the square root of something all over top of 4. What I need to do is figure out what that square root of something is. Negative 121 squared, or negative 11 squared is positive 121 minus 4 times 2 is 8. 8 times 4 is 32, and it'll end up being a plus 32 because it's a negative times a negative. 121 plus 32 would get me 154. Now this would be all well and good. We should check to see if 154 can break down into anything to make it a simpler square root in simplest radical form. 11 plus and minus the square root of something all over 4. Now the numbers that go into 154 are, well, 2 and 120, 75, 76, 77. So 2 and 77 make 154. And 77 is basically prime as far as this is concerned. 7 and 11 are the only things that make that. 2, 7, 11 have no pairs of numbers in it, so 154 cannot be broken down into simplest radical form. So that's just going to be what it is. So my final answers would be a positive 3 halves and an 11 plus the square root of 154 over 2 over 4, and 11 minus square root of 154 over 4. Those are the actual zeros of this. This would be the fully factored form underneath it right here. That's the fully factored form of the original equation.